Most of the time, when we're talking about car loans or home loans, we are talking about something called compound interest. However, in order to understand compound interest properly, we need to go through and look at simple interest first. And there are some circumstances where simple interest is applicable. And that is short-term loans. So for example, if you take your TV to cash converters and put it behind the counter and get $2,000 back, they will charge you simple interest. And then when you want your TV back, you have to give them slightly more than $2,000. Or have you heard of Nimble advertising? Those nimble little loans. If they're over short periods of time, those loans will be simple interest. Same with fixed term deposits. So some of you may have savings or be planning to save when you get older, and the way these savings work is that you put money in a bank account, and say you put $1,000 in a bank account and you agree with the bank not to touch it for 3 months. And you leave it in there and all you can do is watch it. But at the end of 3 months, the bank will give you that $1,000 back along with a little bit of extra. And that little bit of extra is called interest. Right? And that's probably where you'll use it most in real life, is fixed term deposits. Lastly, they're using something called bonds. And bonds aren't the underwear, bonds are a financial instrument that companies use to raise money. Which is cool, but you won't really come across it.
Isn't that for a house? I mean, if you're renting and pay a bond?
Yes. Same word, different meaning. Which is confusing. A bond for a company is basically the company goes into debt and it sells bonds. So it might sell everybody $100 bonds, but it'll sell it to thousands of different people. And it agrees to pay all of those thousands of people $102 back in 6 months' time. And the idea is the company can then take that money, put it towards a new project that will earn it money, and in 6 months' time they pay, or however long time, they pay $102 back to those people. And that's the interest those people earn for lending their money to the company. It allows a company to raise money to invest in research, development, a new power plant, whatever. And that way they make more money, but in order for a company to make money, they quite often need capital or money to start off with. It's like if you're starting a carpentry business, you need money to buy tools, a ute, etc., all those things before you can actually start making money. Companies are the same, it's just on a big scale. Alright, so what affects interest?
Class, rate, and time.
Have you guys seen this last year?
No.
No?
I think that's one.
Yeah.
We did two.
PRT? Oh, you've seen PRT before? Alright. You alright, Ian? Yeah. I was told you left school. Welcome back. I'm one of your age, didn't meant to leave school. Alright, so essentially, interest is the amount of money extra you have to pay back to a bank. So, if you borrow $100 for, say, a year, the bank won't just be happy for you to give back $100. They want a bit extra back. And the idea is, because the bank is taking a bit of a risk when it lends anybody money. If it lends you money for a house, car, personal loan, etc., there's always a slight possibility that you won't pay it back. And in order for the bank to take that risk, they need a return. They need a reward. So anytime you make a risk, generally you want a reward. And the bank's reward for taking the risk of lending you money is interest. So if you borrow $100, at the end of the year they may well ask for $105. And that $5 is what we call the interest. That bit extra on top is the interest. Now what do you think would make the interest increase? What would mean you paying more back at the end of the time?
The
amount you've lent, or the amount you've borrowed. So clearly if you borrow $100, you will only pay back a very small amount, but if you borrow $1,000 or $10,000, or you take out a mortgage of several $100,000, your interest will grow. And the amount you borrow at the start, we call P is principal. Principal. Yeah? Principal. Or amount borrowed or lent at the start. So initial amount. What else would increase the amount of interest paid?
Time.
Time, yeah. So if you borrow $1,000 for 6 months, then the interest you pay back will be relatively small. But if you borrow $1,000 for 10 years, the bank wants more interest. They want more repayment. The idea is that you have a greater risk of defaulting or a greater risk of not paying them back over 10 years than over 6 months. Because over 10 years you might move out of the country, you might get sick and pass away, but over 6 months is less time period. And if the bank lends you $1,000 for 10 years, it means it doesn't have $1,000 to lend to other people and to use. So they've sort of given up $1,000 for 10 years. And they'd rather give up, $1,000 for 6 months, because then they get it back at the end with a little bit of interest. So, you're right, time. And for our equation, time is always in years. So, for example, if you only borrow for 6 months, you have to convert that to years, which is 0.5 of a year, half a year. Can anyone guess what the last one that affects interest is? And the R is a clue. Rate. Good. So rate or interest rate is the one you'll see all banks and companies like Nimble advertising. They have the lowest rate car loans, company finance for 6%, etc. That interest rate changes over time. And about once a month, people called the Board of the Reserve Bank meet the first Tuesday of each month, which all economists get excited about, and they decide whether what's called the reserve interest rate goes up and down. And the reserve interest rate is effectively the interest rate that banks can borrow money at. So banks are really quite safe to lend to. They can borrow money at the reserve interest rate, which at the moment is 3.5%, 4%. You guys are slightly more risky, and you guys have to borrow at a higher percentage rate. And there's that gap in between is really how banks make their money. Because they can borrow at 3% and then they lend at 5%, so that means the gap between is how they make money. But if the Reserve Bank raises the interest rate, then they raise theirs. And in theory, if the Reserve Bank drops it, then they drop theirs. So the interest rate is also another important factor, rate. And we express rate in decimals. So normally it'll be advertised at 6%. For example, 6% is the same as... What is that the same as in decimals, if we want to write a percentage as a decimal?
0.06.
Yeah, good. 0.06. And we get that by dividing by 100. So whatever it's written in as a percentage, we divide by 100 to get to a decimal. Alright. Now, all of those three things combine to make an equation where the interest, that's an I, in dollars, is equal to the principal multiplied by the rate multiplied by the time. Alright? Where the principal is in dollars, the rate is in decimals, and the time is in years. And that will tell us the amount of interest you have to pay back. So, for example, let's say, who wants to borrow money? Kirli borrows a principal of $8,000 for a cheap car, and you reckon you can pay $8,000 off in 5 years? And it's simple interest, and the interest rate is, say, 7.5%. Alright? The question is, what would she actually have to repay at the end of those 5 years? And we work that out by doing interest equals 8,000 multiplied by the rate, and the rate has to be in decimals. So we take that 7.5 and divide it by 100, and we can do that in your calculator, but you'll get that, and multiply it by the time. And now I reach on my calculator. Is $3,000. Now, if Kirli goes to the bank in 5 years' time and repays them $3,000, are they going to be very happy? No, Jade.
Do you have to add the 8,000 and 3,000?
Good, very good. So the total repayment we pay. Yes, it is a lot, and that's the killer about interest. And that's all quite realistic figures. The total repayment is the $3,000 interest plus the $8,000 principal.
Is that how banks make their money?
Yes, fundamentally that's how banks make their money. So for example, I recently took out a mortgage, let's say for argument's sake of about $300,000. If the mortgage is paid back over 25 years, I won't just pay back $325,000, I'll pay back nearly $700,000. So they've lent me that $300,000 and they pay back $700,000. That's fundamentally how banks make their money from this interest. But remember that they also borrow money from people. So if you put money into a bank, they're effectively borrowing it from you. And whether that's just where your ATM card goes, so where your salary or wages go from your part-time jobs, have you ever noticed on your statements how they say interest? And if not much money in there, it might only be a couple of dollars. Yeah, 56 cents. That's about what mine is as well. So if you've only got a bit of money, they'll only pay you a bit of interest. But banks essentially lend money. Say if they lend at 7%, and say they lend, I did finance, so I love banking and money. If they lend $1,000 at 7%, we can work it out using this just for a year. So $1,000, 7%, 1 year. At the end, the interest they earn will be $70. And that means the total they receive is $1,070. Alright? Now, they need to get this $1,000 from somewhere. Banks can't make money. And they get that $1,000 from people putting money into the bank. They might get it from 5 or 6 different people putting it into the bank. But they will borrow money from people, and that's from us putting our wages in the bank, at say 4%. And they'll pay us 4%. And if they borrow $1,000 at 4% for 1 year, at the end, they have to pay all the people they borrowed from a total of $40. So they've lent $1,000, and over the year they've got back $70. And to lend that $1,000, they must have borrowed $1,000. They borrowed $1,000, and to pay for that $1,000, they paid $40. So over the year, they've made $30, which doesn't sound like a lot, but do it with billions and billions of dollars a year, you make billions and billions of dollars. And that's what they call fundamental banking. That's where banks earn their money 101. They also earn money from fees and charges, which is a bit frustrating. They earn money from giving advice to companies, and they earn money from things called transaction costs. So if you want them to shoot lots of money around, then they charge you for it.
Is that what that $2 ATM?
Exactly, $2 ATM. Annoying. Fundamentally, that is how they make money. That's how they've made money since...
There's only one
You're paying for your own money.
Huh?
When the ATM, you're paying for your own money.
Well, I like to think about it as you're paying the bank for them having an ATM there, the convenience of it. Because if they didn't make money from it, it costs them money to install the ATMs and maintain them and make sure they're stocked with cash. If they didn't make money from it, then they wouldn't be there. It's like a balancing thing. Yeah, so when you take out money, it makes sense to take out 200 rather than just 20. Alright, so this equation can work several ways around. For example, if you want to save up for a car, okay? So instead of borrowing this huge amount of money to buy your $8,000 car, you're willing to be patient and save up for it. At the end, you want $8,000, right? So at the end, you want your total to be $8,000. So you want the principal plus the interest to equal $8,000. what you can do is use the equation to find out how much you need to put in at the start. Alright? And that's where we're going to head towards. So how much you need to put in at the start in order to get back a total of 8,000 from the bank at the end. That makes sense? Alright, so before we get to that, I'd like to do a couple of practice questions. So can you go to, where is it? Page 203, exercise 4b, and we'll be using that equation of P equals IRT to calculate how much interest is owed. Yes, I write the equation on the board. P equals, I equals P R T. Alright, so let's go back to Kiraleigh's car question. Let's pretend she still wants $8,000 at the end to buy her car, but currently, P, she only has $5,000. Yeah? Now she finds a bank that can do her a good deal, that will give her a term deposit, but she doesn't know how long for, and the term has a rate of, God, I'm not doing well typing, realistically, probably only about 4.5% at the moment. And Kiraleigh wants to know how long she must put her $5,000 in the bank account in order to get back $8,000 at the end, in total. Make sense? So, if she wants $8,000 in total at the end, how much interest will the bank be paying her? If she puts in $5,000 at the start, and at the end she's going to get back in total $8,000.
It's $3,000.
Yeah, the interest will be the difference between $3,000. So if the bank pays her an interest of $3,000, then at the end they'll pay her the interest of $3,000 plus the $5,000 she put in at the start. So we're looking to earn $3,000 interest. Now our equation of interest equals principal times rate times time can be rearranged like any other equation. In our case, we want to find time. Yeah? So what can we do to get time by itself? Because the thing we want to find, which has our question mark up here, and as you're going through the questions, the working I'd really like to see is for you to write down the unknowns, write down P, T, I, R, all of those, and then you should be able to put numbers next to 3 of them. If you get numbers next to 3 of them and a question mark next to 1, then you can solve the problem. And for all of these problems, all simple interest problems, they all have 4 components. Interest equals principal times rate times time, and if you can put numbers next to 3 of them, you can find the 4th. So here, she has $5,000, she's got a bank account that will pay 4.5%, and at the end, she needs $3,000 in interest. How long will we need to put it in there for? And that's the time. That's our question mark. How do we get T by itself from here?
Divide it by both sides.
Yep, so we need to divide both sides by the P and the R. We need to get rid of these, effectively. So we divide both sides by P times R. And that means on the left-hand side, we have interest divided by principal times rate equals the time. Because the P and R have gone from the right, and then they've appeared down the bottom on the left. Now, it doesn't matter if what we're looking for, the T, is on the right-hand side. The equation will still work, we just need to put numbers in, and our 3 numbers should line up with those 3 letters on the left-hand side. So our interest, what we need, is 3,000, and that is divided by the principal, what she puts in at the start, 5,000, which is multiplied by the rate. Now the rate is not 4.5%, the rate is 0.045. And then we can reach for our calculators once it's all in terms of numbers. 3,000 divided by 5,000 times 0.045. It's 13.333 years. And you can begin to see why people would prefer to borrow some money to get their car earlier rather than try and save just by using interest. Alright. Okay, let's pretend Kiralee isn't willing to wait 13 years. Instead, she only wants to wait. How long would you want to wait? 6 months, goodness.
A year, 2 years.
2 years? I'll say 2.5. Alright, you still have $5,000. This time you want to wait 2.5 years. Alright, and at the end, what do we need the bank to pay us? Assuming we're going for the $8,000 car still. 3. We still need $3,000 interest. And now Kiralee needs to go shopping because we have 3, and she needs to find a bank loan that will pay her $3,000 interest if she puts in $5,000 in 2.5 years' time, which means she'll need to find an interest rate. Okay? Now, this isn't going to be realistic. You'll never get that amount of interest in such a short period of time, but we can use the equation to find out what the interest rate would have to be in order to earn that amount of interest. And we start off with the same equation. Interest equals principal times rate times time. Good. So now we want the R by itself. So we divide by the P and the T. Basically, we can divide by the 2 we don't want, giving us I over PT equals the rate. Now, putting in our numbers, our interest is 3,000 divided by the principal, 5,000, multiplied by the time, and that will get us the rate, which is... Have you guys got it? Yeah, maybe. 0.24? However, that's not quite our final answer, because a rate of 0.24, what is that in percentage terms?
24.
Yeah. So our rate is 24%. Which you might possibly get if you invest in the share market, but not in the bank. Alrighty. So that should help you through the next questions from 3 and beyond. If you need a little more help in the working out, you can look at the examples or ask me. So keep working through the... So let's take a bank deposit of simple interest, which means we're depositing money in a bank. Simple interest, and at the end the bank will pay us back interest. And that's the sort of question we've been working on so far. What we're going to do is look at the difference now between simple interest, what happens with simple interest, and what happens with compound interest. So, let's pretend we deposit a principal of $6,000 for 3 years at a rate of 8%. Now, you've all been using the formula, so you'll know that interest is equal to principal times rate times time. And if we substitute in the numbers, our interest is going to be equal to 6,000 times rate, which is in decimals, so 0.08, times time in years. And that leads us to an interest payment from the bank of $1,440. So, simple interest, if we invest money in a bank, $6,000 in a bank to be exact, for 3 years at 8%, at the end of it, the bank will give us $1,440. Meaning we'll have a total of $7,440. Alright? That's what happens with simple interest. Now, compound interest is a little different. I've lost my pen. Compound interest is different because the interest is added at the end of each compounding period. In this case, we're going to talk about years, and we'll start off with just practicing with years. So interest, instead of being given to you at the end of 3 years, the interest is given to you at the end of each year. Alright, the way that works is in the first year, we start off with $6,000. Alright. Now, for just 1 year, that $6,000 sits on its own in the bank. And at the end of that year, the bank is going to pay us interest. So now we can use our simple interest equation to see what happens during that year. So during that year, our interest is equal to principal times rate times time, which is equal to 6,000,
Can you just wait there?
except this is only for 1 year. But yes, I did. 0.08 times time, but time is only 1 year. So we're only talking about within that 1 year. And at the end of that year, the interest paid is equal to $480. Okay? Which means our total balance will be $6,480. Okay? So, we invested $6,000 at the start, and that 1 year period, the bank has paid us $480. So at the end of that 1 year, we have $6,480. Okay? Now, that's the amount of money we take into the next year. So over the first year, we earned $480. Here, that's the amount we start off with. 6,480 is the amount we start off for the next year with. And once again, we go through the same process, except here, our principal is no longer $6,000. Our principal will be $6,480 because we've effectively earned any interest on the interest we've already earned. So once again, it's 6,480 times 0.08 times 1 equals. My calculator does it for me. That's awesome. So we notice that this gives us more interest than we earned in the first year. And then our balance would be what we had at the start of the year, the 6,480, plus the interest we've earned. So it's the sum of those two, and that is 6,998 and 40 cents. Alright, so then what does that mean for our principal at the next year?
It's 6,998.
Yep. And that means this interest payment becomes 6,998.4 times 0.08 times 1 for that 1 year, giving us an interest payment of 5,559. So, a couple of interesting things when we're comparing simple interest and compound interest. Simple interest, we get paid interest once at the end of the period, and our interest payment was big, at a total of 1,440, giving us interest and the principal. At the total at the end, we had the 7,440. However, with compound interest, we earn interest each year. Each year, we earn interest. And at the end of it, we had more. We had 7,558. Can anyone take a guess at why the interest payments are increasing each year?
Because the principal is
Good, so the principal's increasing. So each time period, as the time goes by, the principal increases. Because what's happening is a little bit of interest we earned from the previous time period is being added on. And then interest is being earned over that entire bit of the previous interest plus the principal. And again, it's added on. So in general, compound interest earns more interest or charges more interest if it's a loan than simple interest as it compounds. Alright? Well, it depends. If you're depositing money in the bank, it's better for us. If you're borrowing money from a bank, it's worse because you're being charged more interest. Alright? Now, this is an example of compounding yearly. So that means that the interest earned is added on each year. The vast majority of loans you'll be looking at for your folio with cars, the interest is added each month. Which means that instead of doing 3 lines, we would have to do 12 for each year. So 36 lines in total of calculation, which is painful. Now, the good news for you is these calculators have a function on there for compound interest. So,
We still have to write it out.
no, you don't. That's the point I want to get to now. Who doesn't have one of these calculators? That's okay. So what will happen is, in tests and exams, you can borrow one of these calculators from the school. However, for classwork, for homework, for folio, you essentially need a calculator. And fortunately, this company offers us a free trial of the calculators from that website. So in the last 10 minutes of the lesson, if you don't have a calculator, what I'd like you to do is to go to this website and download one. The one you download is in fact even better than this one, it's the newer version. Okay, but it does exactly the same, works the same way. If you already have one, then fantastic.
But don't, for our follow, we'll need all the write-up. Yeah. For the follow, we'll need all the...
You won't need all the lines, no. I know there are lots of the lines in the folio I gave you, but that's something different. Yeah, the only time we really do this sort of table thing is to show you the difference between compound interest and how it works over a period of time. Yes, you can go to your little